Question number 12. We're going to be looking at the reaction where ammonia reacts with hydrochloric gas to become ammonium chloride. So this is a reaction that we've seen in class that is spontaneous. However, just by looking at this reaction, we see that there's lots of gas in the reactants, but it combines to form solid only. There's no more gas. So this is definitely something that is unfavorable in terms of entropy. So entropy is going to be less than 0 because we're going from something with a lot of disorder, gases, to something that is highly ordered, solids. So this is unfavorable. But the reaction is still spontaneous. That means that the delta H must be sufficiently less than 0 to make this reaction still favorable. So let's do some calculations. Let's look at delta H first. So ammonium chloride, the heat of formation is going to be negative 314. For ammonia, it's going to be negative 46.1. Remember the negative coefficient, negative 1 for the reactants. And then negative 92.31. This is going to give us an answer of about negative 176 kilojoules. Okay, so this is a pretty large negative number. We're not going to be worrying about the bond energies because this involves ionic bonds. Not going to be worrying about that. So let's move on to the next calculation, the delta N gas. So we're going from 2 moles of gas to 0 moles of gas. So this is 0 minus 2 is going to be minus 2. So work is going to be positive. Do the calculations, is going to be about 5 kilojoules at room temperature. Now this, because it's a positive work, we know that it's work being done on the system. The positive and negative signs are so important. So we know that this is work done on the system. Okay, let's look at the work, the change in the moles of the system. So not just the gas. So this is going to be 1 minus 2. So this is going to be minus 1. Now let's calculate the delta S. So for delta S, we have 94.6 for ammonium chloride minus 192.45 minus 186.91. The 186.91 corresponds to the hydrochloride gas, and then the ammonia corresponds to 192. So now this gives us an answer of about minus 284 joules. So we need to do T delta S. That's going to be 300 joules per Kelvin. 300 Kelvin times minus 284 joules per Kelvin. That's going to equal about minus 85 kilojoules. So delta G is going to equal delta H minus delta S, T delta S. That's going to give us about minus 91 kilojoules. So here we see that the delta H negative was able to overcome the unfavorable negative delta S. So therefore this reaction is still spontaneous.